Hello, welcome back to BLENDERSUSHI Live Noding. We're gonna do another sapling exploration, but this time we're gonna use Sverchok to do the coloring of the leaves. So let's just get started. File, we have the sapling ready, so just create a tree and let's pick up another tree. Last time we chose this one. Let's use Japanese maple. Japanese maple has a lot more leaves, I think. Oh, actually, it has very little leaves. Okay, that's enough. I think that's okay. File, save as. Maple 001 SV. Hopefully this one works as planned, but basically the idea is if we have, imagine this is the leaf and we have a bunch of them, 1, 2, 3, 4, and they are all the same objects with the same number of vertices. If we join them together, this is basically what our leaves is currently like. And we're gonna use cycles and go to compositing. Quickly creates material for it, and let's do a quick test render. Let's give it a color. Okay, that seems to be, that's what we need for now. Let's give this this box the same material as the leaves. Okay, now let's switch to Sverchok. Create a new node tree and use the vertex color. Select our objects, the leaves. Let's do the box first. It's called cube 3, so cube.003, and then we're gonna use the face. I think we use random vector or random number generator just to be more precise. So we need 3 random values, plug into the vector in. We've done this a couple of times. Plug to that guy and quick render. We're not gonna get anything yet because we need to use the vertex color. This object should have SV call. Okay, SV call. Plug into that guy, and currently we have this kind of yellow color. That's because we need to change this to float. Okay, now it's starting to get something. It's gonna be grayscale at first because we need to use different seed for the RGB. Let's say just give it like 50 for now, 50 different color for each faces. Give it a different seed, and now we should have random color for each faces. But what we really want, of course, it's a different color for each object. So how do we do that? Let's have a quick thinking. Actually, I just realized if we are just gonna be coloring the leaves itself is actually a single face, or let me check really quick. Actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually each leaves have 10 different faces, so we do need to use this technique to do it. For for the cube, we actually have 1, 2, 3, 4, 5, 6 faces per cube. So I believe we need to do like a 10 time repeats. I'll explain real quick in a minute. First of all, I'm gonna, oops, Blender just crashes. That's okay. I think I already saved. Let's reload Blender. Blender, reload. Maybe I have too many files here. Maybe folder, Blender. Blender 2000. Oops. Okay. Let's vmaple. File, save as, new file, render. Okay, let's do a quick text viewer. Let's check our color. Switch to text editor and have a look at the data. This is the RGB being generated by Sverchok, 50 of them. We actually need to separate this guy. So for each of the color data here, we need to separate it. We are kind of assuming that each of the polygon face of this cube is kind of in order. So it's gonna be like six of the same color and then 6 of the different color and so on and so on. So that's, we have to do that kind of repetitions. So let's use a list repeater, plug that into that guy, and then let's check it out. Usually the way I do it is like this, so I can compare the data. This is before, this is after, not much different. We want it to be something like that. Okay, that's a bit better. This is here. See, 1, 2, 3, 4, 5, 6 for the 6 faces, and hopefully they are all in order. So we just need to join them back, plug that in, and this guy go into that guy. View, check it out, check the data is not correct. Join level 300. Okay, now so we start with a 50 and then we multiply the data 6 times, so we have 300 data and everything's in order. So I think we are good to go. All this data, we just need to plug it into our color. Okay, now you see the cube now have each of the cube face is getting a single value every 6 items. So we can do the same thing with our leaves. Hopefully it's gonna work as well. So leaves, for the leaves, let's have a look. The leaves actually have 8 faces, or actually 10 polygon faces per leaves. So we have to say 10 here. Now you see, we actually getting the result we wanted. This, some people might say this is a little bit overkill. If you want, you are using, we are actually using the vertex color data for every leaves. Although this actually gives us what we want, so it's okay for our purpose. How many leaves do we have? We don't know, but we just, let's say we have like 150 leaves. And update it. We actually have more than it, maybe 300. Update. Maybe let's, instead of guessing, I'm gonna select the leaves and then make a duplicate, move it to layer number 2, and then go to layer number 2 and then separate this guy, separate by loose part. Just wait a few seconds. I'm separating every leaves, and then I mentioned this many times. With Blender, if you have many objects in 3D scenes, it's gonna slow down Blender. So until they kind of make Blender to handle more objects, we need to be very efficient with the objects. So I'm afraid it's gonna take too long time. I'm gonna actually restart it. Kill Blender and restart again. I'm not gonna separate it. We're just gonna do kind of a guessing. I cannot wait until Sverchok has the color node, RGB node, and HSV nodes. It's super useful to do the coloring, and sometimes I think it's very easier to teach a concept using color. Okay, let's just imagine we have 500 leaves, and then if we switch to this guy now, we should have a different color for each leaves, even though they're not so obvious. I'm gonna save and then save another copy. I have an idea. Let's just turn off the environment color and then make the leaves glowing. You should always name the material. I think it's a good idea. Leaves, material, color. Instead of diffuse, let's use emission. Emission can be pretty boring, so if we mix it with ambient occlusion, it's gonna be a little bit better, I think. Mix shader. Plug that in, 50% factor, and have a look at the result. Okay, they are not too bright. It's a bit dark because of my color management, I suppose. Increase the exposure and gamma. Still a little bit dark, too dark for our scene. I'm gonna turn on ambient occlusion. Doesn't have much effect. Okay, I'll turn on the environment a little bit. Oh, I know why. That's because our tree trunk here is totally black, so we don't get any kind of material. Gonna give it a little bit of color. Tree give it a like dark gray. Although I kind of like the black color trunk. Okay, starting to look quite nice. Sverchok. So currently we keep doing this random number to generate RGB. Like I said, I'm looking forward until Sverchok has the color node. Hopefully soon. Yeah, random color. Random color. Sometimes actually random color can give quite nice result. You just need to be clever about it. Even better is actually if you provide your own color list. Like you can use list list input and then use vector, and then here let's say you have like 5 color or 4 RGB color that you can just plug into that guy list repeater, and then you can use to colorize the tree leaves. Currently looks like the leaves material is too bright, so this better ambient occlusion. Well, somehow the tree is getting the material color once again. Tree material. Wow, okay, that's too bright. I like it, just dark color like that. So yeah, that's pretty much it. Actually, simpler than I thought. Um, the idea here is assuming that each leaves have the same number of phase and then they are in order. In our case, the maple Japanese maple tree leaves have 10 polygon faces per leaves. That's why if we are just generating like a repeating number for like a repeating RGB data for each leaves, multiply that by 10, so it's gonna result in this design. It's really simple actually once you understand, and then I think this is useful concept. So if you are doing this kind of design, you now know how to do it. It's a very basic, but you can get a nice result. So it's not always complex. It's not as complex as you think. Sometimes it's actually from what I think, if you're doing like a complex design like this, the complexity is like more like this. So sometimes what making it more complex is if you're dealing with more data, and then now suddenly the computer needs to handle like millions of data, but the concept like this part you can learn still like quite simple to learn, and you can generate interesting result. Yeah, basically if you understand the basic concepts really well, you can handle any complex problem. Just need it's gonna take more time, but from what we learned so far using animation nodes and Sverchok in Blender, you see that we can do more complex and intricate stuff much easier now. Yeah, so this is the kind of the final result for these explorations. I think we can actually do a little bit more, because currently the leaves have just a single color. I think this can be improved, but I'll let you do that, and I'm gonna leave you right here. Thanks again for tuning in to this live noding. If you have any suggestion and comments and any feedbacks, just let me know down below.